to do. Before we get started, I want to remind us of a couple of things about radicals. The nth root of a to the n is a. So that means if I have the fourth root of m to the fourth, then that just equals m. If I have the cube root of 8, that is the cube root of 2 to the third, which is just 2. And of course, to find 8, we take 8 and divide it by 2, divided by 2, and that's where I get 2 to the third. Okay. The other thing I want us to remember is that if I have something like x to the fourth, I can write that as x to the third times x. So if I want to find the cube root of x to the fourth, I can write that as the cube root of x to the third times x, which gives us x times the cube root of x. So that's the key to doing this, is doing it in this fashion. So whatever the index is, I want to be able to write each base to that power. And then I can pull it out. So again, for example, if I have the square root of a to the fifth. Okay. Well, I know that 5 divided by 2 is 2, with a remainder of 1, which means a to the fifth can be written as a to the second twice, with 1a left over. 2 plus 2 plus 1 is equal to 5. So that's my goal here, is to use these rules to do this. Okay. So here, the first thing I'm going to do is I am going to look at, I'm trying to find a different color pen. Okay. All right, I know 12, if I break it down, is divisible by 2, which gives me 6, which is divisible by 2, which gives me 3. So 12 is equal to 2 to the second times 3. So when I start simplifying this, I can write this as 2 to the second times 3. Okay. I know a to the third can be written, I'm looking for powers of 2. 3 is bigger than 2. So I can write it as a to the second times 1. Times 1a. And I know that b to the 10th, I can write that as b to the second 5 times. 2, 3, 4, 5. So that's b to the second, 2, 3, 4, 5. And I'm sorry, I never leave myself enough room here. Okay, so this becomes, let me write it more clearly down here. 2 to the second times 3 times a to the second and b to the second 5 times. Okay. So everything to the second power I can pull out of there, because I know that the square root of anything to the second power is just that. So I can pull this out. So that's a 2. The 3 has to stay. I can pull out an a. I can pull out a b, another b, another b, another b, and another b. And the only thing I have left in the radical, oh, I forgot my other a, is 3a. So this becomes 2a, 1, 2, 3, 4, 5, b to the fifth times the square root of 3a. All right, on this one, since it's a cube root, I'm looking for powers of 3. So what I'm going to do here is oh, this is not focused well at all. Let me try that again. I'll clear it up a little bit, or maybe it's just my old eyes. Ah, there we go. Okay, so I'm looking for groups of 3. So I'm going to attack this one first. I'm going to do this whole thing first. All right, so 125 is divisible by 5, which gives me 25, which is divisible by 5, which is 25, which is 5. Okay. So I can write this as the cube root of 5 to the third. M is already to the third power, so yay. But I can take n to the ninth and write it as n to the third times n to the third times n to the third, right? So times n to the third times n to the third times n to the third. So let's see what I can pull out of there. So I can pull out a 5, an m, an n, another n, and another n, or just 5m n to the third. Now let's look at the next one. Okay, so I'm going to look at 16. It's divisible by 2, divisible by 2, divisible by 2, and divisible by 2. Okay. So I can write that as the cube root of 2 to the third, I've got 3 of them, times 2. The m, 1 is smaller than 3, so I can't do anything with that. But the m to the 5th, I know m to the 5th can be written as m, I'm sorry, that's an n. N to the third times n to the second. So this is n to the third times n to the second. So I can pull out a 2, have to leave this 2 and the m, pull out an n, and this one has to stay. So that's the cube root of 2mn squared. So now I just have to multiply this and this. So I have 5mn to the third times 2n times the cube root of 2mn to the second. Well, 5 times 2 gives me 10. M, n to the third times n is n to the fourth times the cube root of 2mn to the second. Okay. All right, well, here I've got a square root, and I've got something to the 6th power. So I can write this as the square root. I'm looking for powers of 2. 6 is divisible by 2. So I can write it as t plus 4 to the second times t plus 4 to the second times t plus 4 to the second. So this comes out as a t plus 4. This comes out as t plus 4. And this comes out as t plus 4. There's nothing left in the radical, so this just becomes t plus 4 to the third. Okay. All right, here I'm looking at cube roots. Now, on this one, what I want to do is, the first thing I want to do is I want to split this up into the cube root of 64y to the third divided by the cube root of negative 27x to the 6th. And I'm going to look at each of these individually. All right, so let's start looking at 64. 64 is divisible by 2, divisible by 2, divisible by 2, divisible by 2, and again. Okay, so I'm looking for powers of 3. So this can be written as the square root, or the cube root of 2 to the 3rd times 2 to the 3rd, and then I have a y to the 3rd. So this just becomes, the 2 to the 3rd comes out, the 2 to the 3rd comes out, and the y comes out. Now let's look at the denominator. This is a negative number. I know I can take the cube root of a negative number. So if I start with negative 27, I'm going to pull out a negative 3, which gives me a positive 9. Pull out another negative 3, which gives me a negative 3. So now in the denominator, I have the cube root of negative 3 to the 3rd. Now the x to the 6th, I know I can write that as powers of 3 of x to the 3rd times x to the 3rd. So this comes out as a negative 3, this comes out as an x, and this comes out as an x, and I have nothing left in the radical in either of them, so this just becomes 4y over negative 3x to the 2nd. Okay, let's look at the next one. Now I'm looking at the 4th root. Okay, so I know I'm going to start out and write this as the 4th root, and I'm probably going to have a long one here. So I think I'll do my 48 down here. Well, I don't guess it really matters. I want to make sure I have enough room. Okay, so let's see. 48 is divisible by 2. 24 is divisible by 2, 12 is divisible by 2, 6 is divisible by 2, and I have a 3. Okay, so I have, a 2 to the 4th times 3. Now I know I can write my a to the 5th as a to the 4th times a. 4 plus 1 is 5. Okay. My b to the 8th, I can write it as b to the 4th times b to the 4th. 4 plus 4 is 8. Okay, c to the 15th. Okay, let's see. I can write it as c to the 4th times c to the 4th times c to the 4th. That gives me 12. 12, and I have 3 left over. Okay, so now I get to start pulling stuff out. So I get to pull out a 2, an a B, another B, 3 C's, and what I have left in here is the 4th root of 3a c to the 3rd. So just to simplify it out, this gives me 2a b squared c to the 3rd times the 4th root of 3ac to the 3rd. And there is my final answer. And I forgot to do that up here. Okay. The square root of 200. All right, well, 200 is divisible by 2, which is 100. Now at this point, if you know what the square root of 100 is, that's fine. That's 10 times 10. If not, go ahead and break it down. So this becomes the square root of 2 times 10 to the second. This comes out as a 10, and I'm left with the square root of 2 inside. Okay. Here I'm looking for cube roots. Well, let's see. I know that 81 is divisible by 3, divisible by 3, divisible by 3, and divisible by 3. So this becomes 5 times the cube root of 3 to the third times 3. X to the fifth, 5 is bigger than 3, so I know I can write it as x to the third times something, and that something is x to the second, because 3 plus 2 is 5. So I have a 5, pull out a 3, pull out an x, and I'm left with the cube root of 3x to the second. So that becomes 15x times the cube root of 3x to the second. Okay. All right, my next one is square root. We just did 81, but I'm going to split this up into the square root of 81y to the 7th divided by the square root of 4x to the 8th. But now instead of splitting up the 81s into 3 sums, I'm going to have to put it into pairs. So this is 3 to the second times 3 to the second. And for my y, 7 is bigger than 2, so I can write it as y to the second. That gives me 5 left over, so y to the second. That gives me 3 left over, so y to the second times y. 2 plus 2 plus 2 plus 1 is 7. In my denominator, I know 4 is 2 to the second, okay? Now x to the 8th, 8 is divisible by 2, so that's good. So I know I can write it as x to the second any number of times. So x to the second times x to the second times x to the second times x to the second. I just 2, 4, 6, 8. Okay, so in my numerator, I pull out a 3. I pull out a 3. I pull out a y, a y, a y. And then I'm left with the square root of y. In the denominator, I have a 2, 1, 2, 3, 4 x's. And I'm left with 9y to the third times the cube root of y divided by 2x to the fourth. Okay. Now, let's talk about adding and subtracting. It's just like combining like terms. Okay, so if I have to simplify each of the radicals. All right, so 2 to the square root of x, it's fine. So I can just leave it alone. The square root of 4x, I know the square root of 4x is equal to the square root of 2 squared times x. This comes out, so this is equal to 2 root x. So I have 2 root x minus 10 times 2 root x. Okay. And then if I have 25x to the fourth, I can write this as 5 to the second, x to the second times x to the second, so I get 5 times x, so plus 5x squared. So this really becomes 2 root x. 10 times 2 gives me 20 root x plus 5x squared. Now I'm going to combine anything with like radicals. So I have a 2 root x and a negative 20 root x. So that gives me negative 18 root x plus 5x squared. And that's as far as I can go with that. All right, if I'm multiplying radicals, remember this means the square root of x minus 2 times the square root of x minus 2. And then you've got to multiply it out. Okay. So this becomes the square root of x times the square root of x minus 2 times the square root of x minus 2 times the square root of x plus 4. Well, the square root of x times the square root of x is just x. These are like terms, so I have minus 4 root x plus 4, and I'm done. This next one I'm going to do a little bit differently than I did the one before, because if the indices are the same, then I can put them all under the same radical. So I'm going to start out by writing this as the fourth root of 8a to the second b to the fifth times 4a to the third b to the third. And when I rearrange that, that then becomes 8 times 4 is 32. A to the second times a to the third is a to the fifth. B to the fifth times b to the third is b to the eighth. So I only have to simplify it once. Okay, so 32 divisible by 2, divisible by 2, by 2, by 2, by 2. I'm looking for fourth roots. So this is going to become the fourth root. I've got a 2 to the fourth times 2. A to the fifth, I've got an a to the fourth in there, so that's a to the fourth times a. B to the eighth, well, 8's bigger than 4, so it's b to the fourth times b to the fourth. So this comes out, this comes out, this comes out, this comes out. I'm left with the fourth root of 2a. So my final answer is 2ab to the second times the fourth root of 2a. Okay. All right. Excuse me. All right, so I've got a cube root and I've got a negative number. So I'm going to start and I'm going to see if I can pull out. Well, let me just start with the 135 on this one because I'm not sure. All right, 3, 4, 9. So it's divisible by 3. That gives me 45. Divisible by 3. That gives me 15. Divisible by 3. That gives me 5. Well, since I do have a 3 times 3 times 3, I can make that negative, negative, negative. So this is going to become the cube root of negative 3 to the third times 5. This comes out as negative 3 times the cube root of 5. And I'm done. Okay, if I'm going to multiply, same thing, I'm just going to distribute. So this is going to be 5 times 2, which is 10, minus 5 root 3. 3 times 2 gives me a positive 6 root 6, and that's a 6, minus 3 times the square root of 6 times 3 is 18. I'm starting to take a few shortcuts here. Okay, so this is 10 minus 5 root 3 plus 6 root 6. 6 is 3 times 2, so there's nothing I can pull out of there. But now 18 is divisible by 2, which gives me 9, 3 and 3. So I can pull out a 3. So this becomes minus 3 times the square root of 2. So that gives me 10 minus 5 root 3 plus 6 root 6 minus 9 root 2. None of them are like terms, so I'm done. Okay, I'm going to quit here and we'll continue this on in the next one.